The next speaker is going to be Raul, who's going to tell us about unleashing the power of implicit feedback in software product lines. Benefits ahead.
So, thank you for the kind introduction. This work was a collaboration between Professor David Benavides from the University of Seville and Professor Oscar Díaz and myself from the University of the Basque Country. So this vision paper is about what benefits could bring the incorporation or the use of implicit feedback in software product lines. And what can you expect from this talk? First, a quick introduction about implicit feedback and also about software product lines, as Camilo made in the previous session. After that, I will show you a process for incorporating implicit feedback in software product lines that we proposed in our previous work. Then, the main contribution of this work, that are a list of benefits for 6 different software product lines activities, followed by a preliminary evaluation with 8 practitioners, and I will conclude the presentation with some conclusions. So let's go for a quick introduction about implicit feedback and also product line engineering. So as you may know, there is user feedback, that is what users think or perceive about your applications or software systems. And there usually we have 2 different types of feedbacks. Implicit feedback refers to analyzing the user behavior and how they interact with your application, and the purpose to do that is to then prioritize features, understand how they feel with the software, and also maybe to make some A/B testing. And unlike explicit feedback, which is required the direct involvement of users through dedicated surveys or reviews, implicit feedback is directly mined or analyzed from the interactions such as clicks, navigation patterns, or the time that a user spends in a particular feature. So one important aspect of implicit feedback is that the collection is made usually through usage trackers. Usage trackers are code of libraries that send events to databases or logs, sending the data about what is the users doing with your system. So this is what implicit feedback is and what the purpose of gathering implicit feedback can benefit in traditional applications. And if we move to what software product line engineering is, I will go a little deeper than Camilo or from other side, checking what is domain that software product line engineering is divided in 2 interrelated processes. First, we have domain engineering, that is in charge of building the common platform and also the variability models or the feature models that will describe the different features that are available in the product line. And once that the common platform is built, application engineering would be in charge of deriving the different products of the product line. To do that, they have to first gather the customer needs, and based on those requirements or needs of the customers, they have to make a configuration of the feature model. And after that, the domain implementation or the common platform will be transformed into a product that will only have those features or requirements that were selected in the feature configuration model, in the feature model configuration. Sorry. So we wanted to incorporate implicit feedback into this process, and we thought that a good idea would be to define a new space that would be feedback analysis space, and also extend this process model with 4 new activities. The first one would be to make feedback specification. Feedback specification refers to creating a feedback model that gathers or describes what are the feedback needs that the product line will have. This is made in terms of features, so you will have to define what features do you want to track, for what purposes, and in what contexts. Once that this feedback specification is done, you can start deriving feedback-minded products. And to do that, we define a new transformation that is called feedback transformation. And what this transformation does is to, based on the feedback model, generates what I mentioned before, the usage trackers. It injects automatically the usage trackers into the final product. So after this transformation, you would have a product that is customer specific and also is able to gather what users are doing with their applications. And then this, when you have all the products of the product line deployed and working, you could start gathering feedback and storing it in a feedback log that could be then exploited or consumed by the analysts or the engineers of the whole product line. So this is what we proposed in our previous work that is currently under review. You can check it right in the bottom of the slide. And the purpose of this work was to, okay, once that we have this feedback in the feedback log, what can we do with that, or with it? So we saw that in single application development, the most common approach is maybe to prioritize requirements or try to improve the usability of the applications, but product lines exhibit new activities or special activities that maybe could be enriched with implicit feedback. So the vision of this paper is that in contrast to what we defined here, that feedback analysis is conducted only in domain engineering, we thought that it was better to enable also application engineering and also the management part from the product line to consume that feedback. So in our vision, we would have some products that are generating feedback, different products with different features, but some of them have the same features or some features in common. Those products will generate feedback that is stored in a feedback log, and then this feedback log can be consumed from the different areas of product line engineering, that is domain engineering, application engineering, and the management. So with some discussions and based on our prior experience, we identified 6 different product line engineering activities that we thought that could be enriched or could benefit from implicit feedback. I will now list what benefits we think that could incorporate into each of the activities or what challenges would occur if we want to use implicit feedback there. So in the case of domain engineering, we identified 3 different activities. The first one is automated analysis of feature models. That is what Camilo told us about in the previous session. So here we think that feedback could be used to create new operations inspired by current analysis operations that are being conducted over the feature models. For example, we could, inspired by the dead features analysis operation that tells you what features can't be selected in any valid configuration of a feature model, we could create a new operation that is called drag features. Drag features would be those features that are currently selected and are deployed in products in usage, but then the users of those products don't use it. So those features are available for the users, but then the users don't want to use them. So there could be some usability problem or that the feature is no longer wanted. And here, what we saw as a challenge was to keep the feature model up to date to the feedback data, because currently feature models are thought to represent mostly static data, but if you want to use feedback as an asset to this analysis, we'll have to make these representations dynamic, and this is quite a challenge because current representations are thought for static representations. Then we have feature dependency identification. If you don't know these activities, please ask me at the end of the session or go to the paper for more details because I won't have time to explain each of the activities in depth. So here in feature dependency identification, we think that implicit feedback can serve to validate existing feature dependencies or constraints, or also to infer new ones. And the challenge would be to filter out what dependencies are usable or useful and what node, which node. Because in a huge product line with thousands of features, we could think about a lot of dependencies of usage, because users can interact in very different ways with different features. I can use one feature and then another, or first refer to a third feature and then use the first one. So it would be a challenge to identify what feature dependencies that can be inferred from the feedback are really useful to be documented. And finally, for the domain engineering area, we have SPL testing or testing of the platform. So testing of the platform is quite a problem in product line engineering because it's not feasible to test all the configurations that are available in a feature model. So usually there are some kind of testing prioritization mechanisms to make this testing, and we propose to use feedback as a prioritization mechanism to detect faster issues that can affect in a more heavy way to our users, because if we detect issues that are present in features that are preferred by our users, then we will be able to fix them faster and make the fix available for our users. And here, one of the problems or challenges that could arise would be to end up testing the same features once and again. Because if we only are relying on feedback to test or to select what products configurations we should test, if we only are taking into account the feedback or what are the most used features, we will end up testing very similar product configurations. So a quick solution could be to combine feedback prioritization testing with other testing mechanisms like similarity-based testing. So if we move to application engineering, here we identified two different activities that could be enriched or improved through implicit feedback. First, we have optimal product configuration, that is generating a whole product that is optimal for our optimization function. For example, making a product that maximizes the performance while minimizing the consumption. So here we think that implicit feedback can be used as an additional optimization parameter, where you could try to maximize the usage of particular features or the whole product. And the challenge that we foresee here would be that usage is not always homogeneous and could be context dependent. So if you want to derive an optimal product in terms of usage for a customer or a particular group of users, you will have to take into account feedback that have been gathered in similar situations. So I should have some information of the feedback that I'm gathering about the context where that feedback was collected. And then we have feature-based recommender systems, that are systems that help or assist during the configuration of different products. And here we think that current recommender systems only rely on previous configurations to make these recommendations, but not on what are the real preferences of users. So if we enhance these recommendations with feedback, we could ensure that the recommendations are based on what the users are perceiving or thinking about our features. And here also the challenge would be quite similar to the previous one, because it's based on the context. If we only rely on general usage or feedback, our recommendations, we could end up to ignore the long-tail features. Long-tail features are those features that are less popular, but that they could occur that we have a customer or a group of users that are really interested on them because their particular context has interest on that particular feature. So here also we should have some contextual information about the feedback in order to optimize or customize the recommendations. And finally, in the area of management, we identified scoping as a potential candidate for being improved by implicit feedback. So scoping is a quite broad activity during product engineering. Is defining the boundaries of the whole platform, but here we focused on the scoping of features. And the scoping of features refers to deciding what features will be part of the platform and what other features will transit from optional to mandatory or from mandatory to optional. So here we believe that feedback could be another information source to decide about these transitions. For example, if we have a mandatory feature that is present on all the products, but we saw that only half of the products are using it, so there is half of the products that are deployed of the common platform that are ignoring that feature. So maybe it's that it's not a mandatory feature, but it's an optional, so we could move it to optional. Or if we saw that there is a feature that is not being used in any of our products, then we could deprecate it. And here also, the challenge would be something related with the context, and is to accommodate the importance of the products, because for management, it will be different. Some product or some feedback gathered from a product for a very important customer, or than other feedback that is gathered from some small customers that doesn't bring a good income to the company. So to validate this vision or these thoughts of identified activities, we made a preliminary evaluation with 8 practitioners from Pure Systems. Pure Systems is a leading product line consulting company from Europe. It has its own product line management or variant management systems called Pure Variants. And we performed a preliminary evaluation with 8 of its employees, trying to evaluate what was their perceived usefulness of implicit feedback for the mentioned 6 activities. And we asked a very simple question about that I consider implicit feedback useful for the activity. And in overall, all of the activities were perceived as potential candidates for being improved through implicit feedback. But when it came to scoping and feature dependency identification, at least one of the participants didn't agree with that assessment. So not only for those 2 activities, but also for the whole of them, we would need to further studies to evaluate whether implicit feedback can be a good solution for them. We also asked an open-ended question about some issues that could arise by introducing implicit feedback in product line engineering, not only for those activities. And one of the participants told us that privacy could be a very serious issue because some of their customers are not the owners of the final product, so they develop some subsystems of a bigger system, and it could be very difficult for them to gather this implicit feedback data from when the system is deployed. So to conclude, we presented a new vision for implicit feedback in software product engineering that was previously under review. It also has an artifact. It's an extension to Pure Variants. So if someone wants some demo or wants to read the preprint, he can contact me after the session. We identified some opportunities and challenges for 6 different SPLE activities that could be benefit by implicit feedback. We conducted our preliminary evaluation with 8 practitioners with quite good results. Also, there are some concerns about privacy. And for further work, it's clear that we need to develop for new or test the solutions for integrating implicit feedback into software product engineering, and also dedicated studies for each of the activities. And that's all. Thank you for listening to me.
Questions?
Hi, thank you for the very interesting presentation. Maybe could you expand a little bit upon the challenges you see with the dynamic systems?
No, it wasn't about the dynamic systems, but so you meant.
The representation I meant.
So currently, feature models are some kind of static representation of what are the features of the product line. And if you want to make some analysis enriched by feedback, I think that the most logical approach would be to or move to another representation where you can include the feedback and make the reasoning on this new representation, or maybe another solution could be to, okay, I perform the analysis over the current feature model, but in some way of the analysis, I incorporate the feedback from this feedback log. Right? So what I meant by dynamic was the representation that should be able to keep up to date what is the feedback state of the last version of the product line or the last version of the products. So the feedback that you are integrating in your analysis should be up to date. Should be the last one.
Okay, thank you. And if I may follow up, I wanted to ask on, given all these, promising avenues that you identified, which one do you think would be the best to attack? And do you have an idea of how you would, concretely get down to implementing some of these things?
Okay, so I think that the most probable thing to approach is the automated analysis of feature models, because one of the co-authors is quite an expert in this area, and they have some framework, I think, for reasoning and analyzing feature models. So we have talked about it sometimes to further expand this work and try to integrate a real implementation for analyzing or making feedback enriched automated feature model analysis. But I think that would be something in the future, or for another guy that joins our group. Sorry.
Thank you.
We have time for more questions. If there aren't any more questions, then I propose we thank Raul.
Okay, thank you very much.